Steve Willer is the Business Development Manager at AIRMAP, where he works with airports, regulators, and airspace stakeholders to improve drone safety and situational awareness. Prior to joining AIRMAP, Steve spent 10 years at ESRI, assisting aviation organizations across the globe with their implementation of geospatial technology. Steve is a graduate of St. Louis University with degrees in aviation science and aviation management. Ladies and gentlemen, it is my great pleasure to introduce Steve Willer.
Good morning, everybody, or good afternoon, I should say. It's an honor to be with you here today, and I want to thank all the organizers and inviting me actually to participate here in the event. Before I begin, just a quick introduction. AIRMAP, we're a drone services company that's based out of Santa Monica, California, with offices worldwide, including Berlin and Tokyo. And really, our fundamental mission at AIRMAP is to help open the skies for drones to take flight. And we firmly believe that drones are going to bring incredible everyday value to our lives. And so we're working to open that airspace and to make it come to fruition. So for my presentation today, before we begin and look a little bit towards the future, what I'd like to do is to talk a little bit about where we are today and what's enabled our future to look so bright here in this industry. Now, as a self-proclaimed aviation geek, you know, I'm incredibly excited to be working in the drone industry when you see numbers like these. I really firmly believe that when we look at the history of aviation, we're at a turning point. And this technology represents the next great leap forward with regards to the aviation industry. I would offer that the growth of this technology is actually unlike anything we've ever experienced in aviation before. So if we go back to 2012, the FAA was estimating that there were maybe 30,000 drones in the United States. That number jumping to 500,000 in 2014. And you can see how these projections have grown over time. Now, what's amazing to me about this technology as well is the low barrier to entry. This low barrier of entry is what is going to enable all of us to have new opportunities and to fundamentally grow the next generation of aviators. So again, my background is very strongly rooted in the manned aviation community. I've been a manned aviation pilot for over 16 years now. It's hard to say that. And one of the things that we struggle with in aviation is attracting young people to the career and to the profession. With drones, we're inherently bringing technology, robotics, video gaming, things that children are interested in. And with this low price point, we're making this technology and this future accessible to everybody. All right, so while today we're still in our infancy, the rate of adoption that we've had in the drone industry has been absolutely astronomical. When we look at the number of drones that were sold just last year is a couple million. We look at how many drones were registered with the FAA. Now, 770,000 is a big number, but let's put that in context. In manned aviation, which we've been doing for over 100 years, we have maybe 400,000 civil registered aircraft. Between the time that the FAA opened their drone registry, within a few months, the number of drones that were registered eclipsed and nearly doubled what we've been working for 100 years in manned aviation. It's absolutely astounding. And 60,000 pilots, Part 107 pilots, since that regulation was introduced in August of last year. That's incredible. It's absolutely amazing. This low barrier of entry that I mentioned, if manned aviation could produce 60,000 pilots in a matter of a few months, we wouldn't be talking about these pilot shortages and whatnot that we have with our commercial carriers today. So again, Part 107, introduced in late August of 2016, I like to say that this is a fundamental moment for the drone industry. It really allowed us to open the skies to this technology. So what's the significance of Part 107? It really provided the first operational framework by which people in the drone industry could start to formulate their business and start to work towards economic development, getting their technology in the air, and bringing value to everybody's lives on a daily basis. But it's just the beginning. Part 107 is the starting point. It's going to continue to evolve over time. And as that regulatory landscape changes, it's going to allow us to do more complex operations. I think that all of us can agree in the room here that Part 107 has allowed us to begin the development and the growth and maturity of the drone economy. So here's kind of a sampling of what the drone economy looks like today and what many of you in the room are probably actually utilizing the technology for. I'd like to first acknowledge Greg and his team at CNN for their recent waiver for flight over people. If we could give him a round of applause. I think that represents an extraordinary milestone, so congratulations to your team there. So of course we've got news media and journalism, we've got agriculture, we've got building inspections, we've got insurance inspections and whatnot. But really, fundamentally what all this is starting to lay the groundwork for is it's benefiting citizens in their everyday lives. It's allowing corporations to access data and information at scales they've never been able to access before, which is driving their productivity, their efficiency, and saving workers' lives. So just a couple of numbers to paint the picture here. So a recent study by Drone Deploy, which has helped to facilitate mapping, I believe, of over 10 million square miles here on the Earth already. They indicate that 84% of the mapping that they've helped to support and enable has occurred on models of drones that cost $1,500 or less. Think about that for a second. If you work for a local government or an airport and you want to take aerial photogrammetry, it's expensive. And you program that to happen maybe every 5 years, 10 years, et cetera. Now we can do it every 5 weeks, every 5 days, because that barrier, that cost has gone down so much. If we're a utility or a railroad, imagine the Southern Company, how much it costs them to operate a helicopter on an hourly basis, how dangerous it is for the person out on the skid of the helicopter inspecting that power line or making a repair. They can now do that for fractions of the dollar of what it cost for them to operate a manned aviation fleet. Just a couple other numbers that I'd want to throw at you here real quick regarding infrastructure and the benefit that drones are bringing today to infrastructure products. So this is from PricewaterhouseCoopers that surveyed a construction site project. Basically, the surveying of that site was able to be conducted 20 times faster by the use of drones versus conventional ground-based methods. 91% had a drop in life-threatening accidents on the construction site, which ultimately resulted in savings of 68% in claim settlement litigation and limited fines for environmental violations by 52%. Think about the impact that has with all the talk we have about infrastructure and rebuilding infrastructure here in our country. Think about the impact and the cost savings that this technology can bring to bear. And the last thing that I want to touch on is public safety. Fundamentally, drones are making our lives safer. And unfortunately, we've had a few natural disasters here in the United States that we've experienced recently that have helped bring that to light. So what I'd like to do is just spend a moment and show you a quick 2-minute video courtesy of the Fort Bend County Office of Emergency Management. Fort Bend County is southwest of the Houston area and obviously was greatly impacted by the local Hurricane Harvey that went through.
The Center for Robot-Assisted Search and Rescue at Texas A&M's Engineering Experiment Station has been working with Fort Bend County Office of Emergency Management to provide small unmanned systems, aerial vehicles, and even marine vehicles to be looking at the underneath bridges and the river. What we've been doing is providing small unmanned aerial systems primarily to give aerial imagery so that the officials can see what they're doing to make real-time decisions.
We believe this is the largest formal deployment by public officials of small unmanned aircraft systems for disaster response in our nation's history. These drone platforms working from different elevations have provided our local emergency management team with aerial photography at multiple scales and in high resolution. We have the ability to adjust unmanned aircraft flights in real time to assist with search and rescue operations or changing flood conditions. The teams were comprised of federal, state, and private organizations and agencies from across the United States, all working together to help the citizens of Fort Bend County, Texas.
I think that's some truly powerful imagery, and it really goes to demonstrate the value that the technology that all of you are working to enable is bringing to people's lives. Now, unfortunately, you heard in the video the gentleman referenced, they believe it was the largest deployment of drones by a public entity to date. Well, unfortunately, the week after, we had Hurricane Irma hit Florida. And here's just a quick heat map that shows you the density of drone operations that occurred in the wake of Irma running through Florida. And just to give you a couple statistics here with regards to the scope and the level that drones played in the recovery effort. Now, for Harvey, and these are numbers just for Fort Bend County, which is there southwest of Houston, they conducted 119 flights for 119 discrete mission objectives. They had 13 pilots and they utilized 10 different UAS aircraft. The missions that they performed were primarily centered around damage assessment, mapping levees, bridge inspection, and ensuring that public information was correct, that there weren't rumor control, if you will, is the way that they put it. Now, when we look at Irma, just a week later, we had 247 flights that took place that covered over 500 mission objectives. Right? So instead of one flight covering one mission objective, the responders learned from their experience the week before, and now they were better able to utilize and make more efficient use of the aircraft to cover almost twice the number of mission objectives. And this was done with only 6 pilots and 2 specific models of drones. And primarily their mission there was focused around assessing property damage on behalf of FEMA. All right, so I like to put this quote up when I'm talking about Part 107 and where we are today and help to kind of preface where we're going in the future. So I probably sound like a broken record, but manned aviation, recreational and commercial operations, or private operations and commercial operations, are 2 very distinct things. And the barrier to entry between those 2 is quite a delta, right? Now, a lot of people refer to Part 107 as the commercial rule. And yes, it does enable commercial operations, but fundamentally what Part 107 is a set of operating limitations and pilot certification requirements for unmanned aerial systems, right, within visual line of sight. So if we look at the barrier between operating as a recreational user under Part 101 and operating as a Part 107 user, whether we're operating commercially or recreationally, let's take a look at the current regulatory framework and what we have to do. So Athens Airport is just down the road. It's a Class Delta airport. So for those of you that don't know airspace, it basically means that there's a control tower, and with a defined radius around the Athens Airport from the surface up to a certain altitude is under the control of an air traffic controller. So you need ATC permission to operate in that area. Now, the distance, or the radius rather, of this Class Delta is about 4 nautical miles. All right? So if I'm a Part 107 operator, and let's say a local real estate firm hired me to take some aerial images of a listing. If I was outside of that 4 nautical mile ring, I can access the airspace, as long as I'm flying according to Part 107. So below 400 feet, daytime, visual line of sight, et cetera, or according to any waiver that I might have to Part 107. If I'm a Part 101 and I want to take operator and I'm within 5 miles of this same airport and I want to take pictures of our backyard family barbecue with the new drone my mom got me, I need to now call the airport and notify them. I need to also call the air traffic controller and notify them. So I think this is a great demonstration that shows you how much easier it is to access the airspace with a small unmanned aircraft system now that Part 107 is in place. Take my home airport that I operate out of, a little uncontrolled field in Southern California called Redlands. So we don't have any air traffic controller. We make the same distinction here and there. As a Part 107 pilot, I can pop up my aircraft as long as I'm flying, again, within the limitations of 107, and I don't need to call the airport manager. I don't need to notify anybody, right? It's my responsibility to see and avoid traffic, et cetera, et cetera. Again, if I'm a hobbyist trying to do that same thing, I need to call the airport, right? And the airport manager and notify them. So Again, I think this just highlights the benefit that Part 107's brought to us and the stepping stone that it represents in order for us to grow the drone economy. And then finally, with regards to training and pricing, again, I mentioned the dichotomy between manned and unmanned. So if I'm a private pilot and I want to get my commercial pilot's license, right, I need to go from 40 hours, which is required for your private pilot license, to about 250 hours, which is required for your commercial license. Multiply that by $100, $150 an hour that it costs me to rent an aircraft. You can see what it costs for me to become a commercial pilot, to earn a paycheck flying manned aircraft. Conversely, with Part 107, maybe I shell out a little bit of money for an online study course. Maybe I get some videos for free on the internet, and then I pay roughly approximately $150 fee and go take my written test, and now I'm a certified operator. So the FAA's current projection is for over 1 million pilots by 2020. So what are these folks going to be doing? So I would offer that these pilots are going to start growing the drone economy, and they're driving this economic growth through job creation. So again, 127 billion, some of the impacts within specific industries that small UAS are proposed to have. Within infrastructure, 45 billion. Within agriculture, 32 billion. Within transportation, 13 billion. Within media and entertainment, 8.8 billion. And in the insurance field, another 6.8 billion. So as this technology is being deployed, as more and more drones are going to be accessing the airspace, we need to be able to rethink how we're going to be managing air traffic. So think about this. We're introducing new unmanned autonomous aircraft into the low altitude airspace that our traditional model of air traffic control is not designed to meet. So that brings us to the concept of UTM, or unmanned traffic management. And that's going to allow us to be more automated, more dynamic, and more digital. So it's going to allow us to scale to meet the growing demand of the small UAS community while keeping the skies safe and deconflicting manned and unmanned traffic. All right, so when we look at a timeline of where we are today and where we're going, this is a slide that we use to think about it. So at first, you saw the slide I had that talked about 50,000 or 30,000 UAS back in 2005, et cetera. And I would offer to you that most of those operations were focused mainly around hobby use. So we were kind of figuring out what this technology could do, right? Could it follow me while I was skiing down a slope? Could it take awesome pictures of my epic vacation to Sedona, Arizona, what have you? Now, as the technology's evolved, as the regulatory framework has evolved with it, I would offer that we're now at the beginning stages of the enterprise drone deployment. You're seeing entities such as the Southern Company, such as railroad companies, such as insurance companies, that are outfitting thousands of their representatives and agents with drones. And why are they doing it? Exactly for the reason that I said before, the cost savings that that's going to provide. When we talk about package delivery, that's kind of the sexy thing that gets a lot of the media attention, right? We all use Amazon. We all want a Chipotle burrito delivered to our dorm room. Or if we live in Australia, now we can get a burrito too, it looks like, courtesy of our friends at Google. But fundamentally, while we say package delivery there, what I like to think of is beyond visual line of sight. And that's what we're just at the beginning of now. And I'll talk a little bit more about beyond visual line of sight and some of those enablers here in a moment. But ultimately, we're working towards drones as a service. Drones will be a commodity, right? If you need something done, you could go online, pick up your phone, and have a drone do that task for you, right? It's the whole idea of the service-based economy. And then ultimately, being a resident of Southern California, I don't know about any of you, but I'm super excited about the idea of being able to not sit in traffic and to take some type of personal flying vehicle machine around the city, right? Now, I'm certainly not a Jetsons, sci-fi, pie in the sky type of person, but this is here. And many people predict that flying cars, if you will be here before autonomous automobiles, right? And we can see how far, we all know how far autonomous automobiles have come to date. Just as an example, many of you might have heard, but Airbus, who has created the Vahana demonstrator, they're going to be flying it here before the end of the year at a test site in Oregon. Right? So it's pretty amazing the rapid adoption and the speed at which this has moved forward. So coming back real quick to ATM and UTM and looking forward. So as I mentioned before, incorporating all of these vehicles into the national airspace, it's really going to require a paradigm shift in how we think about air traffic management. Now I know we probably have a number of manned aircraft pilots here in the room. And when you think about jumping in your airplane and taking a trip, you jump in your airplane. If you're in a control tower, you get permission from ATC. You fly from point A to B. You might be talking to somebody, you might not, depending if you're flying visually or under instrument flight rules, right? But the weather that you've encountered, the airways that you fly, the waypoints that you fly to, those are all prescribed and very well planned out in advance, right? So when we're talking about UTM in the low altitude airspace, fundamentally, we're talking about a different environment, right? So what we want to do is we want to take the best things that we know from ATM and we want to apply them to UTM to make it an extremely safe and efficient system. But the difference is we need to apply technology, right? We need to apply technology that scales, technology that can evolve as the maturity of the industry does, right, at a rapid pace. And so what I'd offer to you is that when we're looking at drones flying at low altitude, it's a much more dynamic environment. There's a lot of things happening in this low altitude airspace that isn't necessarily happening when we're flying at 30,000 feet or even cruising at 3,000 feet, right? So many of these elements, these data elements as well, the FAA, it's unknown to the FAA, right? It's things that are known to the local communities. When the local farmers market is, where the critical infrastructure is, et cetera, where first responder activity is happening. So fundamentally, when we look at the different data and elements that the drone or the operator of the drone needs to be aware of in order to successfully and safely navigate the low altitude airspace, we've got a whole plethora of information. And it's centered on airspace data, obviously, and the traditional foundation of the national airspace system. So where's controlled airspace? Where are the airports? Where's the special use airspace? Where's the military flying? What's off limits? But now we suddenly need to know about parks. We need to know about schools. We need to know about government office buildings. We need to know about weather at a completely different level than what we think of traditional aviation weather. We need to know about micro level weather from city block to city block, not point over here in an airport that's 20 miles away. Right? All of these things are going to impact how that drone safely navigates or most efficiently navigates through our communities. A couple of other things that I want to mention, first responder activity. Obviously, first responders might be, or they are today, deploying this technology to assist them in helping to keep us safe. But there's a lot of good reasons that if there's first responder activity happening in our local communities, that airspace, that low altitude segment of area, needs to be blocked off, right? So drones, operators, et cetera, need to know how to navigate around those areas. Wildfires are another great example. So previously, we think wildfires and we think, oh, they just kind of affect us that live out on the West Coast. Well, recent events have shown us that we're all susceptible to wildfires, right, all over the US here. So one of the things, one of the challenges, I should say, with wildfires is that many times they never grow to the size or the scale by which the FAA will issue a TFR, or temporary flight restriction, right? But that doesn't mean that there aren't Forest Service assets or contractors or CAL FIRE or whoever else that aren't using manned aircraft to fight that blaze, right? So what do we do? Well, in this example, one thing that we've done is we've tapped directly into the US Department of Interior's fire database. So the moment any fire is reported across the country, it's logged in this database. From there, we can get that information in real time and we can propagate it out across the industry. All of the OEMs that incorporate AIRMAP data and services, all of the app developers that incorporate AIRMAP data and service, any of the operators that are using AIRMAP's web app or mobile apps, et cetera, have that data available to them in real time. And furthermore, while geofencing isn't required by any regulations, drone operators, and some have done this, can actually implement geofencing around those areas, thus preventing, obviously, the small UAS from either entering or starting up if they're located within those facilities. All right, so what does UTM look like? So rather than put up a complex, well, it's not too complex as far as a NASA graphic goes or an engineering graphic goes. What I've done is I've kind of abstracted it down into a simple simple to understand version, at least for me. So here's the principle of what an unmanned air traffic management system will look like. All right? And I want to draw your eye to the vertical line that separates the government from the industry side. Right? I think we all can recognize, and we might have even heard the FAA say it at various events and other public venues, they don't have the resources, whether they're people or financial, to scale to meet the demand of small unmanned aircraft. Right? So the whole concept of UTM is predicated around industry supplying solutions, and industry being the link between the drone operators and the government systems. So what does that mean? You're looking to take off your drone to complete a bridge inspection, right? Let's say you're in an urban environment that's in controlled airspace. When you start up your drone, you need ATC clearance. Who can facilitate ATC clearance? The idea of the USS, or the UAS service supplier, right? And this isn't going to be one commodity. This isn't going to be one monolithic systems integrator. It's going to be people in the industry. It's going to be an open and level playing field that people can provide the services and operators choose who they want to use based on their mission profile, the equipment they're using, et cetera. And then the USS, companies like AIRMAP, help to facilitate access to the airspace, help to facilitate the safe and efficient planning of your route, and ultimately help you to safely execute your mission, deconflicting you from any other traffic or UAS flights that might be in the area. Now, this might seem like this is this big monolithic concept, but it really isn't. It's not at all. One of the beauties about the way UTM is described is that it can scale up and down. And what do I mean by that? I like to use the term micro UTM. So think about this scenario. Hurricane Harvey hits. Fort Bend County is looking to deploy their first responders and use drone technology. They need to know when, where, and how their drones are flying. They need to coordinate that with people on the ground. They need to coordinate that with the low-flying helicopters and other manned assets that are in there. What do? They stand up a UTM. It's a very powerful concept. The folks at CNN, they're covering a breaking news event. So are their friends at Fox and NBC and CNBC and all of the other news agencies. Well, guess what? They pop up a micro UTM, and now they can all safely deconflict their operations from each other. They've got that situational awareness of where other people are operating. So it works in the visual line of sight. It works for us today, but where this really scales and brings value to the industry is when we look out into the future, right? Which isn't too far away. The beyond visual line of sight, the extended visual line of sight, the more complex operations, the autonomous operations, the operations where there's one person sitting behind a screen at an Amazon factory and managing a fleet of 25 drones that are delivering us our new basketball shoes, right? So when we think about UTM and AIRMAP, we like to think about 4 guiding principles. The first is that UTM needs to be designed to enable highly automated drone. So again, as I touched on already, right now, we're all learning how to fly drones with the sticks in our hand. But it's clear that the future of drones, the scaling of the industry, is going to be a highly automated environment. Drones are going to have artificial intelligence. Drones are going to have sense and avoid. Drones are going to have the ability to make decisions programmatically without the intervention of a human being at all. So any UTM framework must account for this and have the flexibility to evolve alongside the drone technology. Secondly, we must develop performance-based standards to encourage innovation. So we've seen this now in the certified aircraft market. Before, the FAA was very prescriptive when you were certifying an aircraft and the standards that it had to meet. Now we're moving away from saying you must do A, B, C, and D to performance-based standards. And while it might not sound like a lot, it's a huge mentality shift in the way. Because what you're doing is you're not prescribing specific technology that somebody is using. You're just setting, here's the minimum performance standards that you must meet in order to fly beyond visual line of sight, to fly autonomously, et cetera. So if our regulators set guidelines for outcomes instead of specific technology requirements, we're going to be able to harness the power and competition of new development solutions to make the skies safer for all. Thirdly, the UTM framework should be open and democratic, right? So again, I touched on this earlier, but operators, consumers, should have the ability to choose the service that works best for them, right? It's not going to, we can't rely on proprietary technology that doesn't allow for us to move or that restricts innovative solutions from entering the market. And then fourth, we must be able to move more quickly to open the skies for drones. So again, many of you probably have had experience working with the FAA, submitting a waiver for a certain type of drone operation to Part 107. Many of you might have worked with the FAA prior to the release of Part 107 and gone through the entire bureaucratic process that was necessary in order to get your Section 333 in order to operate your drone. We have to have regulation that moves quickly with innovation. All right, so what to watch for? The first thing that I want to talk about here is LANCE. Anybody heard of the LANCE? I heard the acronym, we got a couple people. All right, so like everything in government and industry and every other aspect of life, we love our acronyms. LANCE stands for the Low Altitude Authorization and Notification Capability. Quick show of hands, how many people are Part 107 pilots? Awesome, we've got a lot. Keep your hand up if you've tried to request authorization to fly in controlled airspace. All right, all the hands are up. So you guys are familiar with the process. So let's go through a representative scenario. You get a job to fly a bridge inspection. It's in controlled airspace. You're a Part 107 pilot. Somebody comes to you and say, hey, I got this bridge inspection. I'm going to pay you a lot of money. I just need it done by Friday. It's absolutely urgent. Say, okay, well, that's great. Let me see what I can do. So you go to the FAA's website, you enter in the paperwork, and then you basically wait potentially 60 to 90 days, up to 60 to 90 days for them to process that ATC authorization, right? So what that's fundamentally done, and the FAA realizes this, is it's created a culture of non-compliance, right? They realize that this method isn't scalable. They're getting inundated with these ATC authorization requests, right? So they developed the LANCE program to alleviate that concern. And let's talk a little bit about how that works. So basically what the FAA is doing is earlier this year they put out an RFI. They're working with 12 companies, AIRMAP being one of them, as an initial set to just show initial capabilities, right? What that's going to do is on the FAA side of the house, I'm going to get a little techie here for a second, but fundamentally they've set up APIs, right? Basically endpoints that industry can connect to. So what happens? Now let's take this same scenario. Somebody comes to you, I'm going to pay you a ton of money to do this bridge inspection for me. I just need it done by Friday. Great, no problem. Open up my app, do my flight planning, say, oh, I'm in controlled airspace, request permission through the application. As long as the altitude that you are requesting to fly is at or below the altitude based on the UAS facility map for that airspace, you're able to get instantaneous authorization. What I mean by instantaneous authorization, 5 to 10 seconds, right? That's a pretty remarkable improvement, and I really have to applaud the FAA for taking the initiative to get this done and to do it in a very, very fast timeline in government speak. This has all been done in about 6 months worth of time. Now, while I don't have a lot of specifics that I can share, this LANCE authorization is starting to roll out now, right? So in the next few weeks, you'll probably read different articles, commentary in the media, discussing certain locations here in the United States where this LANCE authorization is now available, and there will be vendors in the community, obviously, that will be making that known to everybody. Pretty incredible, pretty incredible. The national airspace is supposed to roll out in Q1 of 2018, all right? So fundamentally, what LANCE is doing for drones is it's helping to boost our drone economy and move it along the next step in the path, right? You can see some of the numbers here. 500 airport control towers by 2018. 75,000 square miles of airspace are going to be opened up, right? 68% of that airspace will be opened up below 200 feet. That's pretty incredible, right? I have I'm fortunate enough to work with a lot of different industries across, or excuse me, a lot of different companies across the drone industry. Many of these companies that have user bases that are trying to fly in controlled airspace or providing drones as a service to entities say they can increase their business 50% just by having access to the land system. Think about that for a second. That's an amazing number. They're turning away 50% of the business right now. They're not able to facilitate flights by the operators. Pretty incredible. All right. Last couple things I want to touch on in terms of immediate next steps and what to watch for. First would be remote identification. So many of you probably heard in the news recently that the FAA has assembled a aviation rulemaking committee to focus on remote ID. And they just came back with their results, and they were split in terms of what their recommendation was. So what the future remains in terms of how remote ID is solved still is a bit of a question mark. But the technology is there. Lots of people have different approaches on how this can be done today. Everything from proprietary technology to open standards that are in use across other industries, such as the internet and others. So fundamentally, remote identification is something that can be done today. And the reason that that's important is because remote identification is a key enabler to beyond visual line of flight, or excuse me, beyond visual line of sight and flights over people, right? So last December, the FAA was supposed to issue a notice of proposed rulemaking for flights over people. That got put on the side because law enforcement and the DoD says, wait a second, we need a way to identify who's flying where, right? That obviously led to the creation of the remote ID ARC and has brought us to where we are today. So as we look forward, remote identification beyond visual line of sight, again, just like Lance in Part 107 have been incremental steps into moving our drone economy along, these two are the next key enabling technologies that will let us take this to the next level. So in summary, today we're at the enterprise level. Many people are starting to do and are doing beyond visual line of sight on a regular basis. Those are in very controlled environments. They obviously have to have very prescriptive safety and risk analysis cases that the FAA allows them to do that. But we're going to see that become even more widespread, right? And that's going to facilitate, obviously, new use cases of the technology. Convenience in our everyday lives because we can get our Amazon package in 20 minutes instead of 2 days, right? And then moving forward to the future, I will be the first one to sign up to take a ride in Airbus or whoever is able to get that automated taxi to alleviate traffic. So with that, I want to thank you all very much for the opportunity to speak with you, help kick off the event. Hopefully it gave you a couple nuggets that will help to guide discussion and facilitate a lot of thought and interaction during the conference today. I'm not sure what time it is, but I'm sure we've got time for a couple questions if anybody was brave enough to step up. Yes, sir. I can repeat the question too. Yeah. Sure. So for those of you that couldn't hear, the question is, could you tell us a little bit more about AIRMAP's data and services? So the way I like to look at it is we serve kind of three aspects of the drone industry. First, the stakeholder. So we provide applications, mobile applications, web applications that help people figure out when, where, and how it's safe for them to fly, right? So what rules might be in place for them to access the airspace in a responsible manner. The second is all of those data elements that I showed on the pinwheel there. Those are all available to the developer community. So we do that by making APIs available to OEMs and to application developers. So 70% of the drones that are sold today consume AIRMAP data and services in one way or another as part of the flight management system or the ground control station, right? There's over 300 application developers that have also made use of the same data and services and incorporated those into the applications that they're using to serve their community base. And then the other aspect is what I like to call airspace stakeholders. right? So we launched a program about a year and a half ago in cooperation with the American Association of Airport Executives that basically gave airports a digital dashboard and gave folks a mechanism to supply digital notification to the airports if they're flying recreationally within 5 miles, right? So now airports or other airspace stakeholders, Fort Bend County, Texas, Florida Office of Emergency Operations, they can stand up these UTMs and have visibility and situational awareness as to where drones are flying in proximity to their locations.
My question is, how feasible is autonomous drones in the state, and what are the government's rules and regulation which is making hurdles for it, and what is like political stage, or what is the dilemma right now about it?
Okay, so the question relates to autonomous drones and any obstacles that are standing in the way to allowing those flights to take place? Okay, wonderful. I think obviously the big thing is data, right? The FAA has never done this before. None of us have ever done this before. So there's a big need to create data that will inform the safety case and inform rulemaking and policy moving forward. So I think that's a big thing. I think there's technologies out there, sense and avoid, detect and avoid, that you hear of. Those are being demonstrated today. So NASA has a big, obviously, R&D component to it. One of the things that they're focusing on is designing this UTM system and handing over those recommendations to the FAA at the end of 2019. They're doing a series of tests, 4 of them, that they call TCLs, that stands for Technical Capability Levels. And each one of those tests has cases that outline more significant or complex operations. So TCL 1, they started with, okay, can we fly drones safely in proximity to one another, right? High level. TCL 2, they're like, can these drones connect into a national system via a USS and provide telemetry, monitor whether or not they're flying within the volumes that they've submitted, their flight plans, et cetera. TCL 3 is going to be happening this spring, and that's focused on a variety of use cases, one of them being situational awareness. So sense and avoid, detect and avoid. They've got 3 or 4 test cases that they've outlined that the 6 FAA test sites around the country are going to be demonstrating. They're also focusing on CNS links, so communication, navigation, and surveillance. So what happens if the drone loses control, or loses, connectivity with the ground control station? How's the drone going to react to that? What implication does that have to other drones that are operating in the airspace, right, or other manned aircraft? So I think, in summary, at a high level, data is really the key enabler that we need. And so through things like the NASA project, through forward-looking companies such as CNN and other railroads and utilities that are flying beyond visual line of sight today, they're laying those essential elements that will create the data blocks that we need to expand that out to more users. Yes, sir.
What is the process of getting your Part 107 entail?
Sure, so the question was, what does the process of getting your Part 107 entail? It's a great question. So twofold answer. One, if you're a pilot, a manned aircraft pilot, you just basically go online to the FAA's safety website, do a little online course real quick, take a 10, 15 question quiz at the end, and then you can print out your receipt. No cost to you. If you don't have a pilot's license already, you need to take what they call the Part 107 knowledge test. So to do that, you can self-study. There's a number of vendors out there that have provided training materials that will help you, guide you through the different knowledge areas that you need to have awareness of in order to pass the 107 knowledge exam. So things like airspace, reading, aviation maps, aviation weather, aeronautical decision making, things like that. Then you need to find an FAA testing center, and those are generally located near airports. I don't know for a fact, but you probably have one over here at the Athens airport. And there's a fee that each of those testing centers charges, somewhere in the neighborhood of around $150 would be like the national average. You pass that test, I believe, like everything in the FAA, if you get a 70% or better, then congratulations, you're a newly minted Part 107 pilot. Yes, sir. So the question was related to, has there been a lot of work in the area of drone swarms, is what I'll call them. So multiple drones operating in unison. Is that a fair recap? One of the biggest use cases for drones is if the job is dirty or dangerous, use a drone, not a person, right? So we're already seeing that wind inspection turbines, right, power line inspections that I mentioned earlier, those are all jobs that are dirty or dangerous for the human, and they're starting to use drones to do those more efficiently as well as as a safety element. Insurance, right, roof inspections. It's a grimly sad fact, the number of insurance adjusters who die every year by falling off of a roof, right? It's in the thousands, right? I was kind of surprised when I heard that number. Different drone manufacturers are now partnering with insurance agencies and equipping all of their adjusters with drones. As far as swarms go, there are definitely a number of OEMs as well as technology companies that are doing a lot in the swarming space. So swarm meaning multiple drones operating together or in unison. A lot of that's been done obviously at the military level. There's a firm out by us in Southern California that's been doing it with autonomous underwater submarines, which is pretty kind of cool to watch them all kind of get together and flock and complete their mission. And you're seeing more of it come into the civilian space. So we saw it with the Super Bowl halftime show, right? With Intel and creating their light show. So I think swarming technology is there. It's being kind of massaged and perfected. And I think you're going to start to see it go from eye candy, AKA Super Bowl show, to practical application here in the near future. Yeah. Yes, ma'am.
Do you anticipate drones will incorporate ADS-B technology?
Great question. So the question was, do we anticipate that drones will need to incorporate ADS-B? So ADS-B stands for Automatic Dependent Surveillance Broadcast. And basically what it is it's a technology or a little transceiver, if you will, that manned aircraft are now required to have on board. That basically sends out its position electronically. So where you are, what altitude you are, basically telemetry information, right, of the aircraft. There are a number of drones that have incorporated ADS-B onto the aircraft, and they do that to help support the safety case to fly, perhaps beyond visual line of sight or whatnot. And ADS-B certainly can be used in the near term. I don't know all of the technical limitations of ADS-B, but there is a saturation point. So if activity gets to a certain level or so many ADS-B receivers turn on, it will fundamentally crash the system. And one of the FAA engineers at an event I was kind of outlining what that was. So to me, in my own personal opinion, I think ADS-B is great for manned aviation. It's good for unmanned aviation here at the moment, but there are a lot of other technologies that are being researched and tested and demonstrated now to show what I like to call passive surveillance or sharing drone telemetry out across the enterprise. Recently, we were very fortunate to partner with SkyGuide. SkyGuide's the air navigation service provider of Switzerland. So we did a test over Lake Geneva with a number of other partners, Intel, SenseFly, a couple other drone folks. And basically what we demonstrated were all these drones operating at one time, but all of the telemetry was being done over the LTE network. Right? So the LTE network was the primary means for communicating information back and forth between controllers, air traffic controllers, and drone operators. So that's one other technology that's being looked at.
And I think we have time for one more question over here.
Okay. Yep.
With the expanding drone industry and all the applications, how do you see the Part 107 and some of the certifications changing in the near future?
That's a great question. So I think Part 107 is going to be Part 107, right? It's the visual line of sight rule that we saw in the quote from Mr. Lawrence. I think as we move forward and we expand into flights over people, beyond visual line of, et cetera, you will see perhaps equipage requirements that are required for that drone. So again, performance-based rather than prescriptive vendors. I think you're also going to see certification requirements potentially be re-examined by the FAA as well. So if you are the remote pilot in command for some of these more complex operations. They could very well examine putting in minimum qualification standards similar to what we have within the manned aircraft world. So I think Part 107 is very dynamic. It will be subject to change, and how it gets changed, whether they're just straight amendments to Part 107 or new parts that get added to the Code of Federal Register, then that remains to be seen. But it certainly will evolve. Excellent. Well, thank you all again for the opportunity to speak with you. Enjoy the conference. Thank you.